Now that we're back in rows, I realized I could take the dice back out of retirement. So we have choices between dice and bingo rollers. So we've got 2, 9. 2, 9. Josh, you're up first. I haven't asked the question yet. Way to pay attention. Looking up at the board, we've got x squared plus 4, x squared, and x squared minus 6. What is the derivative for each one of those? Okay, for all three? Yes. Because the derivative of the number at the end doesn't matter. So here's where we get into the complication with integrals. If these all have the same derivative, and the whole idea behind integration when you integrate something, you're trying to say what equation did it come from. Like we're saying this is the derivative from what equation. So we have to come up with a system to be able to answer that. Because if I answer this integral, there's an infinite number of equations that could be answered. So what they do, if you are integrating, is at the very end of the answer, they'll have a plus c. And that's going to be called the constant of integration. You're going to end up using it a lot. And the College Board considers it an incredibly important part of the answer. Mainly because you're going to find it's extremely easy to forget to write that in the answer. And when you are doing a lot of free response problems, they will traditionally dedicate one of the 9 points per free response question to you writing plus C. On the answer keys, the scoring guide, plus C, the constant of integration, is most of the time one of the 9 points. So if you have a 4-point problem that's, a lot of work, 4-part problem that's a lot of work, 1 out of 9 points is actually a huge deal. And so they have said many times over the years that you writing plus C is a big part of you showing that you understand how integration is set up and works. So writing this plus C will be a big deal. Letting you know this ahead of time, I will make it a big deal on the test too. Okay? The idea behind it is pretty easy. It's not a big deal. Basically, whenever you integrate, you write plus C. But then, here's where students get confused. There's 2 types of integration problems. These look very much similar. I mean, they're not the same, obviously, that has numbers. They're done somewhat similar, finding the answers, but they stand for completely different things. This is going to be known as a definite integral. I know I've said these terms a couple times, but it's not like you have anything to put it together yet. It's going to be called a definite integral. This is going to be called an indefinite integral. Or antiderivative. Now, I prefer the top terms because it specifies what you're doing. The word definite means that you have an answer that can be defined. These answers will always be numbers because it stands for finding the area under that equation between the equation and the x-axis. So it's always going to be a number. This answer will always be equations. So they represent very different things, and I know you don't really know what this stands for yet, and that's fine. We're going to find the answers in a somewhat similar manner, but they're very different types of problems. The reason everybody has trouble remembering to write plus C is because there is no plus C on a definite integral. The plus C will only show up in the indefinite integrals. And that's because you're finding the area under the curve, so it doesn't really matter about the plus C portion. They stand for different things. And so today's section is going to be really easy to do. We're learning how to integrate actual equations now. But I'm trying to let you know this ahead of time because when you get to the homework, actually today's homework should be only plus C. Tomorrow's homework will involve probably both. But the homework eventually, what's going to happen is you're just going to get two different types of problems. This one will strictly be numbers, that one will strictly be equations. So it's easy to forget the rate plus C. Okay, I am teaching this section very different than how it is in your packet. The first page of the packet actually sort of has this problem. I don't think it has any kind of information really written with it. I think it's just trying to explain how the derivative of all those is going to be the same thing. And I believe that's the way the picture has it laid out. Where is it? Nope, that's our homework. Right there. Okay, well, you're on a different page. Here. So that's what this picture is trying to show you. 3x squared is the derivative to all 5 of these equations. And I don't know, to me, I just don't like to present it the same way. So I realize you have a packet, and so that's kind of hard to compare. I printed this page out for everybody. I know it's in your packet, but I also know it's really annoying to flip back and forth in your packet. And you're going to need this page a lot. And at some point next week, I will have an updated page for you with more correct things. Remember when we learned derivatives? And when we were learning the power rule, product rule, quotient rule, like we did derivatives for quite a while before we learned the chain rule. And the reason I'm bringing that up is, if you look on this formula sheet, you're not going to see a U anywhere. And that's because these are the easiest versions or the basic versions of integration. And at some point, we are going to get to the harder versions of integration that include a U value, like when we learned chain rule. So it's just like saying the derivative of sine of x is cosine x, but the derivative of sine of u is going to be cosine of u times d. So it's that difference between just having an x and having a more complicated version of a same thing. These are only x's. So we're only going to learn the main versions of everything at first, and then I'll show you how to expand it onto the more difficult ones. Because switching to the u in integration it's not that it's harder, it feels stranger than when we did derivatives. Okay, does everybody have one? Perfect. So we've sort of learned some of these properties. Right here, the fourth one down, Oh, the right-hand column is all we're focused on. The fourth one down, we did that in section 4, I think it was. Okay. We kind of did this one in section 4, integrating a regular number. But you saw it differently because you were trying to get a number answer. If you integrate a regular number, the answer is going to be that number times x. And then all of these have the plus c. So that one will make the most sense. If you guys think of a straight line, if it has a slope of 3, what would be the derivative of 3x? 3, because the slope is 3 everywhere. So the derivative of 3x is 3. So if we're integrating 3, the answer would be 3x. Whenever you're going to integrate a regular number, you just basically add an x onto it. 0 is supposed to be the easiest one, and you're going to find it the most annoying and most complicated one. Just because it's like when you first learned the derivative of a regular number, yeah, it's easy to know the answer is 0, but like it took you guys a while to remember it, like for it to kick in, and this is going to be the same thing. The answer is easy, but it's just kind of strange. And then right here, the third property down, we have talked about. If you have a number multiplier, that number multiplier can be brought out front if it makes it easier. Sometimes it does, sometimes it doesn't. These are just properties. The general power rule is what we're focused on today, and pretty much why this is going to go relatively fast, although I've taken a long time talking about it. When we did derivatives, the power rule, you subtract 1 from the power, then multiply it times the front. No, did I say that backwards? Yeah. Yeah, I did. Pretend I didn't say that. You take the power that was there, multiply in the front, and then subtract 1. When we do power rule for integration, we do the opposite order. We're going to add 1 to the power first, then divide by the new power. So we're going to go the opposite order, opposite operations. So I'll say the derivative one again. Derivative 1, multiply by the power, subtract 1 from the power. We reverse that order, reverse the things. Power rule for integration, you're going to add 1 to the power first, then divide by the new power. Now, it's written down in a formula, but make it a cubed, divide by 3. No. So if you have x squared.
Oh, you divide like x3 over 3.
Yeah.
Okay, I see.
Yep.
Okay.
So 1/3 x cubed, if you did that derivative, you would do 3 times 1/3. I think that's the one you were talking about.
Okay, I got it.
Yep. So it is written here. It says the integral of x to the nth. So whatever that number is, you add 1 to the power, you divide by the new power. And it's going to be extremely easy once you have the process down. You just have to remember it's backwards. Now there are trig ones. I don't know if you want me to focus on these or not today. It's the exact opposite. You're going to hate it. Derivative of sine is cosine. Derivative of cosine is negative sine. Now the integral of cosine is positive sine. The integral of sine is negative cosine. So, again, you will hate it. As long as you remember the order, you'll be fine. The way that most people remember this is most people are very good at knowing that the derivative of sine is cosine. And as long as you have one of the 4 down, you're good. So if you know the derivative of sine is positive cosine, then the derivative of cosine is negative sine because it's the opposite. And then if you know the derivative of sine is cosine, the integral of sine, negative cosine, is the opposite. And then the integral of cosine would be positive sign because it's the opposite. So having one of the four down will be okay. That's how I've managed to keep it sane in my head over a lot of years. I remember one of them, and I know the other three because of that. If you would like to memorize all four, go for it. Just going to tell you it'll get jumbled in your head. The integral of secant squared is probably the one that you'll see the most for whatever reason. I don't know why, you just will. These first three are going to be the most popular. But this is going to feel backwards because you'll notice integral of tangent is not here. And you're going to see tangent in sometimes, and you'll want to integrate it, but it's definitely not as simple as what's up here. So integral of secant squared is basically the tangent version that you're going to see. Okay, let's try some together. Nope. I think it's on here, the bottom of the first page. I apologize, it's annoying. It's just, I like to start off with the easiest portions and work harder, and these notes weren't written in that order. Okay, so we've got g prime is 2x. That is basically telling us that we are trying to integrate 2x to find out what the answer is. Okay, let's roll somebody. 2, 5. 2, 5. Yeah. So row 1, 1 through 9, 2, 1 through 9, 3, 1 through 9, 4, 1 through 9. Yeah, but some desks are empty. So do you want me to guide you, I guess, is probably, no? Oh, yeah, I wasn't telling you to come up, sorry.
Wait, no.
Okay, box A, where I just wrote down the integral of 2x dx. That's what I was hoping you could integrate.
Oh, okay. X squared.
Now, are you saying x squared because you know the derivative of x squared is 2x? Probably.
Yeah.
Don't do that. That might be okay later on or something. That will absolutely mess with your brain if you're just trying to work like that, though. So, first thing I would recommend is we know that 2 is a multiplier. We can bring that out front. So we are going to integrate x. And then whenever we get the answer, multiply by 2. Now we're going to use the power rule because this is x to the first. X to the first, you add 1 to the power, divide by the new power, and then plus c. Now we have a multiplier of 2 that we still have to multiply out, so it'll become regular x squared plus c. So everything you were saying was 100% fully correct, but you're going to find that method really difficult because 2x is kind of the one that most people just know was x squared. Are we okay with how I approach that? Okay, so that's kind of how we're going to approach this section somewhat. Monish, do you want to go again? Do you want somebody else to go?
Somebody else.
Okay, so we've got t squared. What I'm going to do is I'm going to write the integral of t squared dt. Oh, nice. There we go. I was about to mark you wrong. As long as you have a variable written to a power, you can integrate it. Now we get to C. You want to choose somebody or do you want me to roll? One, 9. Sean?
Me,
Yeah.
Steve?
Oh, not Sean, Zach.
Yeah. So you add 1 to the power, so it would be 1 over x then?
No, it seems right. Oh, wait. Yeah, you're close. So rewrite it as x to negative 2. Is that what you did in your head?
Yeah.
Okay.
It's going to be x to negative 1.
Oh, I'm getting there. Hold on. Yeah, you were very close to being correct. So if you add 1, you are correct. You get to negative 1. And then you need to divide by negative 1.
Yeah.
So this would be negative x to the negative first plus c. And if you want to write it like this, you can. If you want to write it as negative 1 over x, you can. It's kind of your choice. It's similar to how we did derivatives. Multiple choice answers frequently are written without negative powers. So you just have to know how to change them to get a different answer. So you're going to find that if it's not just x to a power on the numerator, power rule only works with a power on the numerator. There is no such thing as quotient rule or product rule for integration. So you can't leave it on the bottom and work with it. Everything that we're going to know for right now has to be written as a variable up on the top with a power. Can't be divided by anything.
What if you like didn't change it to x to the negative or negative 2 a little bit?
Like, as in you know a different way, or?
Like, is that the only way to do it?
Yeah. That's why I was trying to say, if we were doing derivatives, you could do like quotient rule or something, like a different version, using the same info. But for integration, there isn't a quotient rule. So you have to go by what you have, and we only know power rule for right now.
So do you ever do integration with fractions?
Eventually. But it has to be a perfectly set up fraction, which well, that's why we'll go over it. But otherwise, for the most part, no. There's going to be a lot of equations and things you can't integrate by hand. It's very different than derivatives. You can do a derivative of everything. Integration, you can't. Okay. Wait, I already forgot who we did. Zach. Do you want to choose somebody? Do you want me to roll? Say what?
Alex.
Wouldn't just be sin x.
That sounds like you're asking me.
Yeah, it's just sin x.
Oh, did you just look at the formula sheet?
Yeah.
That's all you need to do. Unfortunately, you would have been wrong if you wrote sine of x.
Plus c.
Still wrong for a minor detail, but important detail.
Oh, theta.
Theta. It's to me, it's definitely an annoying detail, but guaranteed they'll mark you wrong on the AP test if you write a different variable than what they gave you. It's annoying, but you got to get used to it. But yes, trig is going to be this easy. You just have to know it, and you write the answer. It's the same as when we did derivatives. Okay, who's ready for the challenge one? Somebody you want to call on?
No.
Nolan is ready for the challenge one. Challenging only because it has fractions, not because it's set up badly.
I got 8/21 x to the 7/4 plus 3.
Did you just do that all in your head?
No, I had it done already.
Oh, okay. I was gonna be a little bit shocked and like impressed. Okay, so how did you get that? Because I didn't even remember the numbers you just said.
So it's 2/3 x on the top, or like the you get 2/3 x to the 7/4 on top, and then on the bottom, it's divided by 7/4.
Correct. Yeah. No, what you're saying is perfect. So the 2/3 doesn't really affect the answer in any which way other than it'll be part of the answer. So once you make it to the 7/4 power, you technically divide by 7/4, exactly like you said, which is the same thing as multiplying by 4/7. And yes, plus c. So this will be 8/21, which is what I think you said the first time, yeah. I don't think this last one's on your sheet. No, but I feel like you should know this last one. Somebody want to call on? There you go. The derivative of e to the x is e to the x, and so the integral of e to the x is e to the x plus c. Okay, nice. I don't know if I want to teach the next part yet. I want you to practice a lot of power rule before we do things. Let's look at these first, though. We're not going to actually do the answers, but I want to talk about how you would do them. Frequently, you're going to have to rewrite equations so they fit what we know to be able to do them. So the 5e to the t is okay, but 1 over cosine squared isn't on that formula sheet, so you can't integrate it unless it's one of those 6 that you know. I'm hoping somebody here just immediately knows what 1 over cosine squared is. Secant squared, which is convenient, it's on that sheet. So everything trig-wise should be easily changed to what's on your sheet for right now. So this one you would have to change versions to be able to integrate each part separately. So this is what you would end up integrating. You would do 2 separate integrals. Okay, next one. Integral of 3x minus 1 squared. We cannot separate them because the squared has the parentheses grouped together. So you can't take apart individual things. There isn't a u substitution for us to know yet. So how can we change this so we have individual terms with just individual powers and multipliers? FOIL, yeah. You'll actually have to FOIL it out. You will learn a method in a couple sections on how to do this without foiling it, but I will just tell you, some people prefer the foiling method anyway. So you will get options eventually, but for right now, the only way to do it is foiling. Third thing, we did this exact same rewrite process for derivatives. Most people did not want to do this with quotient rule. Do you remember what most people did to change this so you didn't have to do quotient rule? Oh, that's right. I forgot you guys like doing it. Yes. I was never taught that method. So for me, that's not how I visualize it. I forgot in pre-calc you guys did this a lot. Most students here like to bring this up to the top as a multiplier and multiply it out to each term. The way I was taught it was just to divide each one individually in my head. So x squared divided by x to the 5th would be x to the negative 3rd. 4x to the 1st divided by x to the 5th would be 4x to the negative 4. And then 5 over x to the 5th would be 5x to the negative 5. That's how I was taught it. I realize a lot of you like to bring that up and multiply it out. You'll get the same answer. But this bottom one is the only one you'd be able to integrate. You can't integrate the one up here with the fraction. And then the very last one on the bottom is a combination of trick number 2 and trick number 3. Our goal is to make this individual terms with a single power. So you would have to FOIL out the top, get 3 terms, and then divide each term by x to the 1/2. So you would end up with 3 separate fraction powers. You're going to hate integrating fraction powers at first. After a while, they seem like the easy problems, so then you don't mind them. Okay, I just wanted to talk about rewriting before we got to the homework. On the homework itself, so I'll pause and wait for the last portion. We'll do that at the beginning of the hour tomorrow. On the homework, you're actually not going to do much of the homework. You are only going through, I believe, 14. Correct. You are only going to be doing this first page. And I'm really hoping that you guys will realize to stop wasting a lot of the time when I give you guys to work in class. Some people are great about it and they just work really hard. Others immediately pull out their phone, start watching videos, listening to music, whatever, and it's not shockingly usually the back half of the room who chose their spots in the back half of the room, except for you two. You didn't choose back there, I forced you there, yeah. So keep your phones away. Try to get it done during class today. That way you will not have any type of homework. You won't have to focus and do any calc at home tonight. You'll just be like caught up, have extra free time.